Hello, everybody. I'm Albert, the dinosaur, and today we're going to learn about section 5.5, solving equations. Yes, I like to solve trigonometry equations. Maybe someday I'll be able to get out of this egg if I can just solve the trig equation. This is a 2-day lesson, so it can get complicated, but we'll keep it just to the basic ones, like trying to crack out of this egg. All right, guys, let's watch the lesson.
Okay, so this is section 5.5. We skipped 5.4 because it's just more of the rules that we don't really need. Nobody ever does section 5.4. 5.5 is the main thing, solving a trigonometric equation. Basically, what you're going to do, instead of me saying, okay, tell me what the sine of 30 is. You say 1/2. We go backwards, say, what angle has 1/2? And you'd say 30 degrees. But is there more than one? If I say half, you're like, well, there's another half. It could also be 150. So this is how it looks in paper. Okay, so instead of doing all the homework that was posted on Google Sites, we're just going to do this shortened version with the basic ones, because this could get really confusing using all like the trig sheet and stuff. So these ones you won't have to use the trig sheet too much. So let me show you how to do the basic trig equations. This should be fun. Okay, so here's your most basic equation. Notice there's an x here. So you're trying to solve for x. Sine of x is 1/2. So what you do is you kind of go backward. You look at your trig sheet to try to find 1/2. But they want to know all the answers that are 1/2. Every single one of them. So I go, okay, sine 1/2. Now the book does everything in radians, but I'm going to do it in degrees because it's just easier to keep track of. So let's just try to do degrees only. 30 degrees, but is that the only one? Oh, here's another one. 150 degrees. So I have to put both of those down. So I'm going to say x is 30 degrees, and I'll do it again. X is 150 degrees, but you're not quite done because some of the questions you'll just say, find all the answers from 0 to 2 pi. They might put a bracket and say 0 to 2 pi and include them if I did radians, or well, if I'm doing degrees, they'll say 0 to 360. So if they say name all the angles from 0 to 360, well, I did. Here's from 0 to 360. These are the only answers, and I would be done. However, some questions say, instead of just telling me all the answers from 0 to 360, some of them are going to say, tell me all the answers, like to infinity. So remember our wheel, our unit circle, how we can go around the 360? Well, what if you kept going around again, and around and around and around and around? So we can go around and around and around. Remember, like coterminal angles? So what you do on your answers is you do this. You're going to write those two answers, 30 degrees and 150, and then just say plus, you can do another 360 degrees. You could say, okay, why don't you add 360? What if I want to add another 360 or another 360 or another 360? Then they're going to put an n here to say n is any number that's an integer, like 0, 1, 2, 3, etc., etc. So you can add as many 360s as you want. So you could go 390 or add another 360, 750. So same here. I could say 150 plus, you could just keep adding 360 over and over and over. And this is your answer. So once again, if the problem says, just tell me answers from 0 to 360, just say, well, there they are. But if it says, tell me all the answers, like to infinity, you'd say 30 plus as many you want to add on, or 150 plus as many as you want to add on. Okay, so that's your most basic question. Let's get a little fancier. Okay, this is example 1, finding all solutions. Okay, they want me to do the 360 thing. And by the way, if you kind of looked up here, here's somebody doing in radians, and see how it can get like, it can get a little confusing. That's why I'm just going to do it in degrees. Okay, so here's the problem. Oh no, it looks like an algebra equation. And once again, we need to solve for x. So let's get x on one side. But remember, x is kind of trapped, right? It's got the sign in front of it. So let's get this all together. Let's combine like terms. Let's get these to one side. In fact, let's get all of this together. I could bring this over here, or it could go the other way. I think it's easier to go like this. Minus 3 sine of x. Just like you would go minus 3x. Imagine this said 5x, and this said 3x. Wouldn't you get those together? So let's just bring this over to this side. That way it'll be positive. So 5 of these, 5 cookies, minus 3 cookies, is 2 cookies. What's a cookie? A sine x. So we did that. We got rid of this. We got rid of this. So now you have these numbers like -2, and you have -1. So you have the x on this side. So let's get x by itself. Let's move the numbers to the other side. Just pretend it says like 2x. 2x minus 1. Okay, move the number to the other side. So now we'll go, let's see, add 1, add 1. So now we have -1 equals 2 sine x. Okay, we're almost done. Now you've got this little sine of x almost alone, except there's a 2 in front. Well, imagine it said 2x. Wouldn't you just go, okay, it said 2x, I'll just divide by 2. Divide by 2. So now it says -1/2 is sine of x. So now I got to figure out, okay, we got this alone. Oh, what angle has -1/2? Trig sheet to the rescue. Of course, I could go on my calculator, go second sine, but remember when you do it on the calculator, it only tells you one answer. It tries to find the closest answer to 0. So let's find all the -1/2s. So I grab my sheet. Here's my yellow trig sheet. And let's see, -1/2. Okay, oh, negative's over here. 210 and 330. 210 and 330. So I'm going to say x is 210 degrees and x is 330 degrees. Oh, wait, I'm not done. It wanted all the answers. So put on this, n times 360 degrees. Put the little degrees so somebody doesn't think you're doing radians. So now you can say 210 plus that, like 570, plus another 360, like 800 and whatever I'm at. And those are your 2 answers. Okay, so you can see that in the book. And here they are doing it in radians, and they get down to that, which is 210. 11 pi over 6 is 330, and they say 2n pi. But it's probably better if they said n times 2 pi. So they're using 2 pi instead of 360. But you see how it's easier if you do it in degrees? Okay, let's try a harder one. Okay, here's what's new on this one. What looks new? There's a 2x in here, but the 2 is inside. See, before we had sine of x, but this 2 is trapped. I do have this alone, but there's a 2x. Let's not worry about it. Let's just go, okay, sine is all by itself. There's nothing left. Just think it says sine x. Look this guy up. You can't do anything with this right now. Just kind of pretend it says sine of x. But I know there's a 2x. Look this guy up. Fractal 3/2. So I go, okay, find my sheet. See, okay, I got 60, and we got 120. Okay, so, but I'm not done. This is why this is tricky. Okay, so we had 60 degrees plus n 360. I'm gonna leave some space. Plus 120 plus n 360. It means as many 360. You might think I'm done. But here's what's different. There's a 2x here. So I got to bring this down. I figured this thing out, right? What sine is radical 3/2? But you bring down this 2x. If the 2 weren't there, I would just go, yay, I'm done. But there's a 2. So I have this, solve for x. So you have to go, oh, okay. Divide by 2. So this is always the last step. If there's something in here, it's the very last thing you do. Divide by 2, divide by 2, and divide this by 2. So now your answer says 60/2 is 30 degrees plus n times 180. Okay, I'm going to do it again for this one. Here's why that works. Here's the reasoning. 30 degrees. If you put 30 degrees in here, what's 2 times 30? 2 times 30 is 60. Oh yeah, the sine of 60 is radical 3 over 2. The sine of 60 is radical 3 over 2. So it's like 2 times 30 would give me 60. Okay, so I'm going to do it again for this one. I bring down the 2x, divide by 2, divide by 2. And don't forget this thing over here. You actually divide that by 2. That's where people forget. And I have to go, oh, I have to give you half credit. You forgot that part. So 60 degrees plus n times 180. So these are our answers. All the answers. If we said, give me all the answers. Because if you put in 60, that's 120. And you could say like, oh, what if I added 180 to that? That's 240. And you could plug that in. Okay. Remember, sometimes they say, don't give me all. Sometimes they say, oh, why don't you just do to the 0 to 2 pi thing? Or in our case, because we're doing degrees, what if I said, I would like you to specifically list every answer from 0 to 360? If I said that specifically, just 0 to 360, you'd go, okay, well, 30 and 60, right? What, did you get them all? Did you add 180? Normally, if you add 360, you're over the limit. Oh, what's 30 plus 180? 240, yeah. And could you add another 180? That'd be too much. Well, how about this one? 60 plus 180. That's two, whoops, wait a minute. 30 plus 180, 210. Whoops, my bad. 30 plus 180, 210. I'm looking at this one. 60 plus 180, 240. There's 4 answers. So if someone said, give me all the answers from 0 to 360, you would actually say 30, 60, 210, make that a little better, okay, 210 degrees, and 240. Yeah, you'd list 4 answers. So it's actually easier if they say, just tell me what they could all be, but sometimes they say, specifically tell me them. So 2 different ways that you could answer. Okay, let's try another one like that. Okay, here's example 2. This one's tangent. Tangent's a little different. Okay, so we've got 3x is 1. So let's look up tangent. There we go. Okay, got my sheet. Great, I made this sheet. So tangent 1, 45 degrees. But guess what? Yes, there is another one. But for tangent and cotangent, you don't have to list the other one, because what happens, these repeat exactly in the same order, but 180 degrees later. In fact, you may remember that tangent, if you did the graphing, you did tangent's graph repeats every 180 degrees, or pi. Unlike sine or cosine, that it takes 360 to go all the way around. It then happens again. So here's what we do. We look it up. You only have to find the first one for tangent. You do not have to find the other one. Just find it, 45 degrees. So, okay. So what is it? It's 45 degrees plus, but instead of doing 360, you're going to do 180. So whenever you have tangent or cotangent, you're going to use 180, okay? Because these numbers actually repeat every 180 perfectly. So there you go. But wait a minute. Oh, we've got a 3x. So let's bring down the 3x. 3 times something is 45 plus multiples of 180. So we got to like, okay, if it was just x, I'd be done. And let's just say we're saying like all answers, right? Okay, let's divide by 3. Whoop. Divide by 3. Divide by 3. Don't forget to divide the last guy. So now I got x is 15 degrees. Because if you put 15 in there, 3 times 15 is 45. The tangent of 45 is 1. Okay, but then this here, 180 over 3. N times 60. This is your answer. You only have to write one of them. That's all of them. And if somebody says, oh, no, I want you to tell me all the ones from 0 to 360. Actually, could you please list them for me? Like, oh, okay. 15 degrees, and let's see, add 60. 15 plus 60, 75. Just keep adding 60. Add 60 to this. 135. Okay, add 60 to that. 195. Add 60 to that. 255. Add 60 to that. 315. And I'm going off the paper. And add 60 to that. Oh, that would be too much, wouldn't it? That'd be 375. Too far. There you go. So if they say all, we're good. If they say, could you please list them all? And you're like, okay, 15 plus 60 plus 60 plus 60 plus 60. All these numbers, if I type them in, I get a tangent of 1. In fact, I think I'm going to try it. I'm going to go tangent of 3 times, let's try 195. 195 and close it. And it says 1. Hey, cool. All of these numbers, if I plug them in, give me 1. All right, let's try a more difficult one. Oh yeah, you know how easy I made that? Here it is in the book, but they do it in radians. There we said 45. We said 45, but they did pi over 4. They divided by 3, pi over 12, n pi over 3. And then here's why you don't really want to do radians. Oh my God, here they're trying to list them all. This is confusing, isn't it? That's why I say, go ahead and do degrees. Okay, I lost it. Here's another one. This one's x over 2. Once again, we'll look him up, and then you're going to multiply the 2. Okay, so I've got my sine all alone. I got this. We'll look this guy up. Radical 3 over 2. Look him up. 30 degrees, but whoops, sine 60 degrees. And remember, I got to find the other one. For sine and cosine, you actually have to find them both. Here we go, 120. Okay, so remember we had 60 degrees. And then regular sine, we're using 360 again. For sine and cosine, we use 360. Okay, only if you get tangent or cotangent do you do the 180. And what if I had something weird like secant, cosecant? Well, they're also 360 because those are just these. Okay, so I got one. The other one I looked up was 120 plus n360. I'm like, oh, wait a minute. There's an x over 2. So instead of dividing by 2, the 2's on the bottom. We'll put the 2 on the top. We'll multiply by 2. And this guy also. So your new answer would be 120 degrees plus multiples of 720. And likewise here, multiply by 2. So multiply by 2, 240. Multiply by 2, n times 720 degrees. And there's all the answers. If they said, could you please list them? Like the book actually says, could you please list all the ones? I would like you to list them for me. Sometimes you're done. They say, oh, okay. Let's see, 120, add 720. Oh, that's too much. Okay. 240, add 7. Oh, that's too much. And you'd be like, oh, that's it. That's the only 2. Because if you put in 120, if you wanted to check it, and you put in 120, well, 120 over 2 would be sine of 120 over 2 would be sine of 60. And of course, the sine of 60 is radical 3 over 2. Sine of 60, trying to lose it there, radical 3 over 2. Okay, now we're going to do a tough one. We're going to do a factoring one. Okay, I want to give you a more advanced one. I want you to try at least one of these factoring ones. Not too difficult, but this is your most basic factoring one. Doesn't it look like Charlie Brown thing? Kind of like x squared plus x plus a number. I'm thinking, hey, factor equals 0, the 0 property. Has to equal 0. If some of the stuff's on the wrong side, please bring it over. This will be like number 39, I think it was. You're going to factor. Okay, don't get scared. You see this? Cosine, cosine, cosine. That's the word. Put cosine x, cosine x. Cosine times cosine is cosine squared. Okay, how about 1? 1 times 1 plus times minus, positive times negative. Oh, wait a minute, that's 2. Let's see. Let's look at the middle. We've got a cosine here. Let's see, here's 1. If I put the 2 here or the 2 here, we have more. This guy's doing the positive and this guy's doing the negative. Let's put the 2 right there. So now you could check it all out. You can do the whole Charlie Brown thing. Cosine times 2 cosine is 2 cosine squared x. If it gets confused, just pretend it says 2x squared. Just pretend it's x times x, x squared. Cosine, cosine, cosine squared for the 2. 1 times -1 is -1. Here's this. In the inside outside, I'll do it in green. Here's 2 cosine x, 2 cookies. Here is -1 cosine x. 2 cosines minus a cosine is 1 cosine. Okay, so the reason I factored is because, wow, this is too hard to figure out. But if I factor in the 2 baby problems, since this and this both are 0, we break it into 2 mini problems. This could be 0, or this one over here could be 0. Remember how we factored? You factor to find the zeros. So is it this one that's 0 or this one? Because something times something is 0. One of these has to be 0. So when you see this, don't get scared. Cosine, cosine, cosine. There's a 2, 1 times 2. Now you get 2 baby problems to do. Let's solve this. Okay, cosine x plus 1 is 0. Wait, let's get this alone. Remember, get him alone. Move him to the other side is -1. Look him up. Where's the cosine -1? Okay, push it a little small here. Cosine -1, I see 180. And that's actually it, isn't it? In fact, I should know that. 180. Oops. 180 cosine is -1. So I could say, okay, we'll write our answer. X is 180. Oh, plus n360. Don't forget that. And ooh, this is already alone. Cool. So I don't have to go like 2x and divide. Now we look this guy up and like, oh, wait, let's get this alone. I gotta get cosine alone. Here cosine was alone. Let's see. I'll move the 1 over. Just pretend it says 2x minus 1. Add 1, divide by 2. Move the 1 over. Equals +1. Okay. Pretend it says 2x. 2x is 1. Divide by 2. Divide by 2. Because the 2's out here in front. It's 2 times that. It's not inside. It's out in front. You can divide it. Okay, so now I have cosine x is 1/2. Okay, let's look that guy up. Because I got cosine all alone. These are pretty cool. Hope you feel really smart right now. So cosine 1/2. I can go, let's see, I got to find them both. I have 60, and I have, way over here, I got 300. So I got 60 degrees, plus n360. And I got 300 degrees, I think it was. Yeah, 300 degrees plus n360. And if they said list all, I would just be done. I'm like, yay. If you want to do it in radians, you may. They do have this as their example 4. Okay. That's pretty much as hard as I want to get. If you want to look at a little fancier, you can look at example 5. And you're like, oh, I'm going to start using some of the rules. I'm like, tangent, wait, I got stuff on both sides. Bring it over to one side. See, they bring it over to get to 0. Now factor this. You're like, oh, this is weird. You know what? They both have a tangent. Maybe I'll just undistribute the tangent. See, they both had a tangent. How about I just factor it out, undistribute it? And they got it like that. Give this guy a little parentheses. You could say, yeah, you should have a parentheses because you came out, boom, boom. And now I got the 2 baby problems. Tangent of x is 0. And this one, and then like, oh, I gotta solve this one. Add the 3. How to get rid of a square? Square root. Okay, so I'm not gonna test you on one like that. If we were in class, we could get into some more of these and really get into some challenging ones. So if you want to learn a little more, the book does have more examples where they get fancier, and sometimes you even have to pull out some of those rules from earlier in the chapter. You would have to pull out like double angles and stuff. And so they could get kind of neat. And the book's got some really wild ones. But either way, I want you just to start here on 11, and we'll do the basic ones. Start with 11, do the odds. This says find the all, so leave the 360. Over here it says giving to 0 to 2 pi. How do you go up to 31? So actually, please list all the numbers. Try a factoring one. And these ones are already factored down here. All right? So have fun. You get 2 days to do this. And on Thursday, we'll do like a practice test. And Friday, a real test to show off your trig knowledge. And to get credit, take a photo of your homework. Okay, so take a photo of your homework. If you can't take a photo, then type in your answers.